Latson, and we are going over arithmetic. Reason we're not going over math knowledge. Don't worry about this. I definitely did not write it wrong. Don't worry about this overview. I was just testing to see how to do it or how I should get this formulated. There's going to be, a couple things I think we should know, a little bit of equations, just a little bit of practice problems, and the test, which I'll go over more of that later. So, correction. First off, I think we need a calculator. I know it says we don't need a calculator, so until I get more confirmation from Major B or one of the cadre, it's just confusing because they're expecting you to know geometry, some geometry stuff. But I mean, I guess for now, don't use a calculator. But there's something on the quiz where I'll talk about it later. But don't bring a calculator, but still know the formulas, as if you do need one. You have 25 questions and you need to answer them in 21 minutes or 29 minutes. That's about a minute and 5 seconds, roughly, I guess. I didn't actually do the math, but that's a good amount of questions, and some of them might be a little hard, some of them might be a little tricky. So let's talk about some general things I think we should know. You need to know what a factor is. So, factors are just any multiples of a number that's more than one. If it is a factor and you can only divide it by 1 like 7, it's a prime number. Any factors that can be multiplied by more than one factor. So like if I give you what is the factor of 12, you're just going to be like 12 is going to be 1, 12, 2, 6, 3, 4, and that's it. This is a factor and it is a composite number because it can be divisible by multiple numbers. Let's talk about rational and irrational numbers. Rational numbers can be expressed as a over b, and usually these are going to include all integers. Refresher, integers are positive or negative numbers, but not decimals. They're whole numbers and they can whole positive negative numbers. If they're a decimal, it's not an integer. Irrational numbers, think of this like you're repeating decimal places, I would say. So like pi, we all know that's like 3.1415 something 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 something. Think of the letter E, which is 2.14 some, I believe, as well as the square root of 2. I'm not even going to say this one, but they all have like a very common, their numbers are just always repeating and repeating and repeating, and there's not an actual definite ending. That is what an irrational number is. It's pretty much just as long if it doesn't have a very good ending, if it doesn't end, it's not rational. Don't really know how to explain it that well, but I mean that's like the general concept. Mixed numbers and improper fractions. Mixed numbers are improper fractions, just looking a little better if that makes sense. So like first off, fraction. I'll just go talk about fractions real quick. You're gonna have your numerator, your denominator. Pretty much simple. A proper fraction's numerator is always gonna be lower than its denominator. If your denominator equals 0, it is considered undefined. And anytime you get a fraction, almost always reduce this. Usually it's going to be by a common factor, but simplify it anytime you have a fraction. Unless it is a proper, mixed number and proper fraction. So, like if we wanted to have a mixed number, let's say equals what, 11 9. Oh, sorry about that. Okay. So, this on the left is a mixed number. This has a integer plus the fraction. That is what composes a mixed number, integer and a fraction. A improper fraction is only a fraction, but like I said, the numerator is not going to be above the denominator, which makes it improper. Usually, anytime you're getting a question asked, and it's like, what's the, and it gives you like an improper fraction, you usually just go with improper. I think improper is a little better than having a mixed number, but unless it specifies a mixed number, that is when I would say use the mixed number. But usually just try to keep it in that improper fraction form unless it says mixed number. because you can't really simplify it without making it into a mixed number, and mixed numbers are still improper fractions. So let's talk about adding, subtracting, and dividing fractions now. I will talk about adding and subtraction first. Whenever you add or subtract a fraction, the one thing that you need to make sure that it does is have the same common denominator. It's very important because you cannot add these without having the same denominator. Usually a good rule of thumb is just multiply them by their counterparts. So if we want to make this simple, just multiply this entire equation by 4, and I will do the same with this one by multiplying it by 3. This 3 goes here, this 4 goes there. We're going to get 8 twelfths plus 3 twelfths. These are now multiplied, so now their denominators are the same, which means you can finally add this together, which gets you 11 over 12. Oh, I was scared. Now, if I were to tell you to subtract these, which I will, to just get that ready for a subtraction. So let's say I wanted to get you to subtract this. Well, you're still going to have the same common denominator, except it's going to be a little different. It's going to be 8 twelfths minus 3 twelfths. Well, now that it's subtracted, we do the same method, and instead of adding it, we're going to subtract it, but you only subtract the numerator. Like, you already done all the work with that denominator, and now you're going to get 5 twelfths. So, just to recap, anytime you're adding or subtracting, every single fraction has to have the same denominator. If it does not have the same denominator, you're going to significantly struggle, but most of the time you're not even going to be able to get through it. Like, you have to have a common denominator. Moving on, I'm just going to use the same one. Let's say that we wanted to multiply these two numbers. Get out, 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 out. Alright, let's say we want to multiply these numbers. So, I'll just do this. When you multiply, understand that you are not cross multiplying. The only time you would cross multiply is if it was like this. This is when, or like x over 4. Yeah, that's an x. This is when you would cross multiply these numbers, and we'll go over that later, but it's a common mistake that you would automatically cross multiply. But no, you're going straight across. You're multiplying that numerator with that numerator, that denominator with that denominator, which becomes 2 twelfths, and you always want to simplify your fractions. So the answer is actually 1/6. But understand that when you multiply fractions, basically, or a basic fraction, do not do that cross multiplication. That is for something else. Very easy to get that confused. If, let's say we wanted to divide now, 3/4 divided by, definitely mess something up, 1/5. A good method I use is called the KCF. Burris uses the KCC apparently, which basically what the K means is to keep the first fraction. You want to change the sign of the second, or the division to multiple to change it. And then I use flip, he says change. They mean the same thing. You're flipping this fraction upside down. So now you get 5 over 1, which allows you to multiply regularly. So it'd be 15 over 4. This is very much an improper fraction. And if you wanted to, you could just mix it up and get 3/4. So very simple, very basic. When you have to multiply or divide a fraction, you don't have to worry about that common denominator, but if you add and subtract, understand that you do actually have to worry about that common denominator. So let's keep going. What else do I have? Alright, next. Converting decimals to percentages, percentages to fractions. Or, yeah. So I'm going to do just very easy ones. Alright, just simple. If we were only given a decimal, to find percentages, usually all you have to do is move the decimal place 2 places to the right, or just times it by 100, whichever one, makes it easier for you. Same thing with if we were given 625, becomes 62.5%, because all you need to do is multiply these numbers, or just multiply by 100, or just move that decimal place 2 places to the right. Same thing with this one. If you want to move from percentage to decimal, divide it by 100, or move it 2 places to the right. They work pretty easy with each other. Now, if you ever get, let's say if you ever get, let's say you're trying to make percentage fractions. I mean, I think a good way to get it done is to go 25 and add that 100, simplify it to the best of your abilities. Easiest way to get fractions, I guess. But if you do want to get it, all you gotta do is divide that percentage by 100. It gets you the fraction pretty easily. Um, what else? What else? Now, let's say you wanted to get this to a fraction. What they say to do is to multiply it by 10, which makes no sense. They want you to multiply the whole fraction by 10 until the decimal's gone, then you reduce it. I don't think it's really important. Most of the time, because it's arithmetic reasoning and you don't have that much time, the answers are going to be really easy. It's not going to be some weird bomb number that makes no sense. Just, I feel like we should all know how to multiply and divide, or how to convert from fractions to decimals to percentages. They're usually going to be very easy to understand because, like I said, you don't have that much time. What about a direct and indirect proportion? I don't really think this is going to be on the test much, but really what a direct proportion is. What am I pressing? Okay. A direct proportion is if we get an x and we're going like this. Okay. So a direct proportion basically means that as you move up, as the x goes up, the y goes up with it, which actually this correlation makes no sense. Because what this means is, let me use an example. I'm trying to think of a good example that makes sense. Okay, so a direct proportion. So the more times I study, which is x, the higher my grade is. That is literally all it means. It is just as x goes up, y goes up with it. As x goes down, y goes down with it. And indirect proportional is exactly what it sounds like. It is indirectly related. So in this example, I would say the more I study, the worse my grade got. Doesn't make sense because it's not really how studying works, but that is the general thing. The more x goes up, y goes down. X goes down, y goes up. It's indirectly related. They're still related, but not directly. Next one. Probabilities and ratios. Probabilities means the likelihood of something happening. So it's in order to find a probability, you're going to use this form, and it's going to be the number of outcomes desired. Please don't worry about this handwriting. So yeah, number of outcomes desired over the number of possible outcomes. So if it's more like if I flip a head coin 5 times, you want to get like how often would you get heads? We all know it's 50%, but if you didn't know it's 50%, there's only two possible outcomes, heads or tails. We want heads, so that's one. The number of total possible outcomes is 2 heads or tails. That's how you get it. It's literally just going to be the number of the desired outcome versus over the number of possible outcomes. That's all probability is. I don't really think you'll get this on the question on the test, but understand probability just a little bit. Ratios are going to be a more comparison. So They usually are designated by a semicolon. 7-to-1 ratio. For every 7 things, 1 time. It's used to compare two quantities, and it's also reduced. It's If they can reduce it, they're going to reduce it. Treat it like a fraction. If the answer is 14 for every 2, it really is 7 for 1. It's just easier for you to reduce it. There is no, like, I don't really think there's any way to, like, formulate. You just gotta do it. So now we're gonna do just a couple practice problems. Very, very easy practice problems. So I'm not really gonna read it. I'm just going to circle the very important information. So if this patient is given 1,000 milliliters every 2 hours, per 2 hours, how much will he receive after 5? Well, we can just multiply this, or add another one, because now this is how much he gets in 4 hours. Half of 1,000 is, or yeah, half of 1,000 is 500. So he's actually getting 500 per hour. Add that 500 down here. And in 5 hours, he is getting 2,500 milliliters. And that is pretty simple. Why are you doing that? Pretty good. I think this is a very easy portion of the test. The geometry portion, I think it's really hard. So what about this one? This one talks about ratios. There is a 12-to-9 ratio. So 12 females for 9 males. Please ignore the handwriting. There is 48 females in that, there's 48 females in the evening class. They have an exact ratio, so how much males are there? Well, a good way to do this is understanding if it's the exact same ratio, to go from 12 to 48, you just multiply by 4. Which means all you gotta do here is multiply by 4, 9 times 4 is 36, which means there's 36 males. There's also another way to do it. You can, I believe it's x over 48, I think. 26. So it is 9 over 12. Nah, it looks funky. There's another way you can get it, I think. I'm just really dumb, and I don't really remember it. Give me a second to pull it up. Wait, I was actually right. Okay, so what you would do is find that ratio, 12 over 9, which equals 48 over x, because we're trying to find the males. Cross multiply, which gives you 12x equals 48 times 9. 48 times 9 is 432. Divide this by 12, and x equals 36. Now, use this if the ratio isn't exact or it's not as clean. But I think this method of just multiplying both by 4 is a little bit quicker than that, because it doesn't really need a calculator. I mean, it does, but it doesn't need that calculator that bad. So let me erase this now. Next one. What is 20% of 160? Well, pretty easy. 20% of 100, that's where we get this. Multiplying this, well, we need to figure out what is blank percent of 160. We don't know what 20% of 160 is, so that's our x, but we do know what 160 is. What you need to do now is go 20 times 160, which is 3,200 equals 100x. Divide this by 100. These cancel out, which becomes 32 over 1. So x is just going to be 32. So 20% of 100 is 32. Or 20% of 160 is 32. You just need to use this method, the fraction method, to accurately do percentages. That's literally all you have to do. I'm sure there's a simpler way, I just think that's pretty easy in itself. So if we were to do this again, what is 130, which is over 100? So what is 130% of 70? We don't know what 130% is of 70, so we need to find that, but we do know that we are looking for 70. So same thing like last time, we're gonna get 100x equals 99100. I'm just gonna cancel these numbers out anyways, which leaves us with 91 because well, x, if you were to cancel it out anyways, you just get x equals 91 because 1 times x is still x. So pretty easy, which actually checks out because 91 should be over 70 because 130 is over 100. So 130% of 70 is 91. Let me erase this. So now we're doing an employee is making $88 per day and he's given a raise. First off, gonna understand this raise is $12. What percentage increase was his daily wage? So a good way to do this, it's gonna be called new, or the formula is the new amount minus the old amount minus old over the old amount again. So if we were to put this into practice, we're going to get 100 minus 88, so that new amount minus the old amount over that old amount. We're going to get 12 over 88. Plugging this into a calculator, the answer is 0.136, with the 136 continuously repeats. I'm not going to be writing that 136, 136, so 136 with the 136 repeating, and we're trying to find the percentage. So the percentage is just multiplied by 100, which means that he is getting a, what the hell? He's getting a 13.6% wage increase. That is how you find it, like any increase. New amount minus old amount over that old amount will give you what you're looking for. So just a couple more quick things to mention. A range. These are called central tendencies. They might show up as like which central tendency is better. What central tendency is this. Not really something I know, but just there. Range is going to be from the high minus the low. Range is only using 2 points on a graph. Mean is just going to be the number of whatever you're looking for. So it's just the number of x's. Like you just add x1, not just x1 plus x2 plus x3 plus x4 and so on and so on. Just how many values you need to put in over the amount of values you put in, which is just going to be n, which in this case is going to be 4. So there. Mode is going to be frequency. It's going to be how often you see something. Whenever you have one mode, it's going to be the highest peak. There is chances where you have two modes. This is called a bimodal. Not really important, but this is usually when you just have like this peak and it goes like this, and maybe you have even a third peak, but like these are your main two peaks. So this is peak 1, which has a really high mode, and peak 2. Your median is the center of all your points. I know there's a way to solve it really quickly, but you just have to know it's in the middle. I don't really think it's that important, and I think even if it is important, it's very something we could pick up really quickly. Right triangles will be the next thing. Let me move this down. Alright, so this is a right triangle. A, B, C, doesn't need by this. So this right here is called your hypotenuse. It is the longest angle. Usually it's going to be the longest angle. It's usually the longest angle. Yeah, this is usually 45, 45. That's 40, 45. Whenever you ever try to find a triangle angle, you use what is called the Pythagorean theorem. I'm not going to spell that out, but the formula is a squared plus b squared equals c squared. As far as I know, this only is for right triangles because it has a hypotenuse. So anytime you're asked to find the length of something and you're given a regular triangle, just cut it in half. Cut the triangle in half and find the hypotenuse for there. Literally, any triangle can be made into a right triangle, pretty much. So do it. You're gonna save a lot of time. What else did I have written down? Yes, so you use this to find the length of any side. As long as you have, let's say you have, you're trying to find A, you have B and C. You're trying to find C, you have A and B. You're trying to find B, you have A and C. You will find every angle as long as you have 2 points. Ah, man. I don't like this next one. Erase this. Let's see, let's continue the road. Alright, in this next slide, I'm going to be showing you a little bit more about the areas. But areas, there's 2 areas. You have the area, which is just the area of a 2D square, or 3D, whichever you're fancying. It is going to be just the inside of it, what fills up that space. You have a surface area. Now this includes the area of every single side. Wait, okay, scratch that. The area is just the area of that side, one side. So if you're trying to find the area of a square, it's that one side. If you're trying to find the area of the cube, that is where you find a surface area. Because the surface area takes into account for every single side of the cube, and area just takes account for one side. Whatever I just said, Reese, earlier, scratch that, it's this one. When we're talking about base, no, I forget I can draw. I don't know why I'm trying to explain this. So, if I were to ask you just what the area of just this bottom platform on the ground, you would tell me length times width. But if I were trying to find the area of the whole cube, this is where we get surface area. Surface area is designated by S, and you would do length times width. Since it's a cube, we just have to times it by 6 because they're all the same size. But there's a formula for when you get a rectangular prism, a triangle prism, just any of that. You don't have to worry about surface area on 2Ds. You just have to worry about regular area. If you get a prism, that's when you have to worry about surface area. Base. Now, let's do this. So, triangle. This is a rectangle now. Okay. This is not a, this is a messed up rectangle. But if I were to ask for the base, your base is this and this. This is designated by length times width, and this is your height. But your base is gonna always pretty much be that length times width. Or if it's the base of a triangle, 1/2 base times height. This is very important to understand because it differentiates from a lateral. These are laterals. These are the faces of the four sides. They're called laterals. So if I ever ask you like what is the surface area of a rectangular prism, whenever I have a big B means base plus 2 laterals, or plus the lateral, because there's 4 laterals, you add them all up together. You're very lucky that these laterals are all the same sides, because it's a rectangle that has 2 different sides, or 2 different laterals. You have to account for both of those and add them as well. I'll get more into that on the later one next to this. It's just something that I wanted to say now. Now, you have to understand how to find the area of a square, a rectangle, and a triangle. That's pretty simple. I don't really think it's very important to have them to know the area of a rhombus, kite, or parallelogram. But just in case it comes across, just understand it. As far as I know, you do get a sheet. Everyone says you get a sheet. Okay, I think I totally just cut myself off. But these are some areas to talk about. You know the area of a rectangle. Rectangle is just gonna be length times width. You know the area of a square. Side square. That's all it is. Or maybe length length square. Does that sound better? Maybe it looks better. I'm not sure. It's literally just gonna be the square. If you square them, you get the area of the square. Rectangle length times width. Yada yada yada. You're not parallelogram. Your triangle is gonna have that 1/2 base times height. This is your height. And the reason why you do 1/2 is because you're taking into account that you split it in half. Not really important to know why. This is a parallelogram. They look like this. That looks like a kite now, but it's not. It's a parallelogram. And it's just going to be that length times height. I forgot where the length is. I think it's right here. And it goes height, something like that. Then you have your rhombus and kite. I do not think a rhombus is very important, but apparently it is. This is a rhombus, by the way. No, this is a kite. I don't know what a rhombus looks like. I also don't think it's important. But understand these areas just a little bit more. It's very important. So, let's see. I already talked to you about what are lateral areas, which is the combined area of all lateral faces. I'll draw it out in 2D real quick, just to make sure that you understand what I meant when I said lateral. 2, 3. So this is a rectangular prism. These are your bases. This is why you get that. You add these two bases up, or in this case it'd be 4 times 3. So 4 times 3 times 7. Okay. So the reason why this right here says 2b, if we're trying to find the surface area of a prism, is you're trying to find big B. Big B, or base, is just 4 times 3. You multiply it by 2 because you have two bases, right here and here. So 2, 4 times 3, plus your lateral sides. Your lateral sides are just, what, 4 times 7. And because there's 4 lateral sides, you times it by 4, and you add that as a unit. So the answer would be 4 times 7 times 4. And this is how you would find your surface area. Like if I were to solve it, we'd get 24 plus 48, or 28. Oof, 28. Dude, I don't even know. 20. I'm done. My brain's not working right now. Don't worry about it. But this is what you would do. Now, if these were different sides, like this was skinnier. I don't know if you can see my cursor. If this was skinnier than this one, it would be 2L for, let's say these two were the same side, they're same length, or width, I guess, and these were the same width. Then you would have to do it like this. Not really something I think it's going to be hard to grasp. It's all just like understanding the general idea, I feel like. Let's see, cones. I don't know if I want to draw a cone real quick. I guess we'll draw one real quick. I really don't like cones. Cones, cylinder, pyramid volume. Oh god. Oh god. Oh man. Okay. So we're just gonna talk about this real quick. This is surface area. We're including the roundness of it. That's what a surface area is. And the volume is what goes inside. This is a cone. This is your base. These are your bases, by the way. And you find the pyramid volume right here. This is your base. These are your lateral sides. Not really much to explain other than as long as you like understand how to find the area. It's pretty common, I feel like. Now I will say if we're using no calculators, I still don't understand what the point of knowing an area is. But I put it just in case because it wasn't a textbook. And I feel like we should be able to use calculators, but it looks like we're not. So just understand a couple about the areas and stuff. There's what the heck? What is going on? Yeah, I don't know what's going on. Yeah, it tweaked out at me. I don't know what happened. Anyways, if I ask you how to find the surface area of a cone, oh my god, what's going on? This is how to find the surface area of a cone. It uses pi a lot, and also this stands for the radius. So that radius of that circle right here at the bottom of the cone, that's what r is. But I don't think you'll need to know this. I genuinely don't think so. It's not like it's not important, but I just don't think it's that important. If I were to give you the volume of a sphere, this is also the volume, and the surface area, this is what you would have to do. Like I said, I don't understand why this would be important if we're not allowed to use calculators, so just understand it, but don't worry too much about it, I guess. We're going to move on to the last one, but I got to manually do it, so. Okay, this is the last thing that I think you should know, besides knowing how to a lot of formulas. Common denominators, I talked about it a lot. We all should know what a common denominator is. It's just when, the numbers have the same denominator. This is a common denominator that they share. The least common multiple is going to be the least common thing that these factors have. So like 24 and 12, I believe it's how I would say it. So like multiples of 24, it's going to be 2. Oh wait, do I want to do it? Wait, okay. I don't want to do big numbers because that's definitely hard. Okay, scratch what I said about least common multiples. It's different. So least common multiples of 5 and 6. Watch. So it goes 5, 10, 15, 20, 25, 30, 35, 40. Common multiples of this: 6, 12, 18, 24, 20, 24, 30, 36, 42, and so on, so on, so on. If I ask you for the least common multiple, understand that out of these, what number shares that they share, which is 30. They will share another number. So if we were to keep going, they go 45, 50, 55, 60, 42, 48, 54, 60. Now, while they do share 60, that's not the least common multiple that they can go to. The number would be 30 because that's the least common. That's like the lowest number that they can multiply and have the same number. Whenever I ask you for the greatest common factor, it's just going to be like, what do both of them have in common that we can simplify to? So, what is something that they can both simplify to? The answer should be like what, 2, right? So they can both be simplified by 1/2, I think. I'm not entirely sure, alright? It's hard to explain it because we do it naturally, but basically the greatest common factor is what can both of these fractions be divided by and simplified. I believe. That is, I'm not entirely sure though. I apologize. I do it so naturally. I do it a lot. I don't understand how to explain it. Sorry. Some other things to know: the greatest common multiple, which is just the opposite of the least common multiple. The greatest. I don't really think they'll ever ask you that, but just understanding. Fractions that can be changed to the same denominator are called a common denominator. So, like whenever you're about to subtract or, add, you have to find a common denominator. Yada yada yada. I think I already just said that though. Yeah, that's pretty good. There's not much to really say about fractions. If I ever give you an ordering of the rational numbers, let's say we get 5/8, 23%, 0.62, and 28/4. If I were to tell you to order these in rational numbers, the first thing you should do is understand how each of these work in decimal percentages. So 5/8 becomes 625, 0.23, 0.6, 2, and 7. We want to order it from least to greatest, and we can start out with the fact that 23%, and then go to 0.6, 0.58, or 5/8, my bad, 2, and 28/4. Whenever you answer them back into the way that they were originally written. Anytime you're ordering a rational number, try to just get them all in one format. So in this case, get them all in that decimal format, and it should be pretty fine. You're not really going to see as much, but it's just like on the safe side of, hey, at least I know. Let me get on the last slide. So this is the last part. You just need to take that practice test. It's attached to the PDF file. I will have a walkthrough. I will walk through it later today when I post it. I know this was really long and probably not very. It was okay, and I think I can get better if for going forward for any of the others. If there's anything wrong, like I know I should probably add more examples to make it a little easier. I just don't want it to be too long because math is really long as is, and I'm already really tired of talking, and that's I have class in like 20 minutes. Um, if it's something's wrong, just let me know, and I will try my best to. I will try to fix it for the next videos. I will tell you now that the last 5 questions are kind of complicated because they need a calculator, and I was unsure why we can't use a calculator. So I guess don't do it. If it looks like it really needs a calculator, don't do it. But other than that, it should be good. You know, 15 minutes. You have 17 minutes to solve 15 questions. I have not posted the answer sheet yet. I was just going to do that after a couple hours after class. Um, so thank you. And if there's anything that I should fix, please let me know so that this is more informative for you because I wasn't really sure how I could make this work. I could also have these PowerPoints look a little more informative instead of just relying on my slides and or my notes on the side. So it's just my general background knowledge. So hopefully this made some sense. If I can figure out how to add timestamps, I will, so that you can skip past if you already know it. If not, I apologize. I will probably just have a little thing in the comment section next time. So, that's it. Thank you, and good luck on this portion. I will be around whenever. So if you ever need help, I'm right here. And